All right, so got to read that problem. So there's two different types of, two different grades of decaffeinated beans, and one of them's only $4 per pound, and the other's $7 per pound, right? The shop wants to blend the beans to form a 90-pound mixture of the two that's worth 5 a pound. So we got to figure out like how many pounds of each grade of bean should be used to make the mixture. Okay, you know our first thing to do is, so we've got 5 pounds, $5 per pound for one, and then the other one is 7 per pound. We've got a total of 90 pounds here. Okay, and then that's what we want, and then we have a $4 per pound grade. Okay, so how much of each grade do we need? Those are our two variables, right? So let's say let x, well, you know what? I don't really have an x and a y, so yeah, so let x be the amount of $4 beans in pounds, right? And then we'll say let y $7 beans in pounds. Okay, so and then we're going to make a 90-pound mixture. So if we add the total amount of $4 beans and the total amount of $7 beans, they're going to add up to 90 pounds. So we can say that x plus y, this is the total of each type of bean, is going to be 90 pounds, right? Now each pound of the x value is worth, sorry, the x beans is $4, right? So maybe I should change colors there. Let's do that. So $4 for each of these, this type, right? The cheap one that I called x. That's plus it's $7 for the other type of bean, the more expensive bean. 7y equals, and then we wanted the total amount of weight we know is 90, right? And it's going to be $5 times the 90 pounds. Right? We know it's 90 pounds and we want it to be $5 per pound. So that's the amount. Okay, so I can simplify that a little bit further. So just let me rewrite this again. So I've got a system here. X plus y equals 90. And we have 4x plus 7y. Oops. Oh, that doesn't look good. Let me fix that. 7y equals 450, right? Alright, so now we have to decide, am I going to do substitution or elimination? And, you know, it doesn't really matter. We could do either, but I think that since we have x and y isolated, I'm going to go with the root of substitution. So let's say I'm going to let's isolate x. So I'm going to have to subtract y to both sides. So let's say we're going to say x is equal to 90 minus y. Okay, now I'm going to go ahead and substitute. Pick a new color. Let's see. Here's a color. So I'm going to substitute into the other equation. So 4 times, instead of x, I'm going to substitute 90 minus y plus 7y is equal to 450. I'm feeling like I might need to use my calculator soon. So distributive property here, 4 times 9 is 36, so that's going to be 360. Minus 4y plus 7y equals 450. All right, let me subtract 360. So, and then I'm going to combine those terms. So it's going to be 3y. And if I subtract 360, let me just show that. So I'm subtracting 360 to both sides. Okay, we're going to have only 90 left. So y is equal to, that doesn't look like 90. Let me repair that. Okay. Oops. What happened? Okay. So that's 90. And then when I divide both sides by 3, I'm going to get 30 pounds for y. And then it's pretty easy to get the x value because it's just 90 minus 30, right? So x is equal to 90 minus 30. If I substitute 30 in here, okay, is 60. Okay, so let's just check this out. Those are, yeah, those would add up to 90 pounds, right? Okay, so it's 30 pounds of the $7 bean and 60 pounds of the $4 bean. We already know that adds up to 90, but let's just double check. Let's just double check and make sure that it checks out with, so if we had $4 and then that's just 60, right? Okay. Plus the $7, we have 30 of that. Is that going to be equal to 450? So this is going to be 240 plus this is going to be 210, which, yeah, that works out to 450. So it checks out. All right, good.